So we're going to be talking about redox now before we go on to balancing, which we will do, and net ionic equations, which only happen with single displacement and double displacement. But because most of our reactions in the world fall under the category of redox, we need to talk about it. Redox is short for oxidation reduction. And all this means is there's an electron transfer going on. So if something is oxidizes, it loses electrons. If something gets reduced, it gains electrons. So the oxidized becomes more electropositive, the reduced becomes more electronegative. So this number will go down on the element and this oxidation number would go up. You cannot have oxidation without reduction. They go hand in hand. If something is giving up an electron or two or three, something else is taking them on. So let me show you what I mean by that. I'm going to give you the example of silver metal reacting with copper 2 nitrate. Now you know all your nomenclature, you know all your ions, you know your polyatomics, so we should know our charges. Anything that's elemental has a 0 oxidation number. We know nitrate always has a -1, and there's 2 of them for a total of -2. So copper has to be in the +2 state. Because copper is more active than silver, this will give us a no reaction. But if we mix it up and do it the other way, and we say copper plus silver nitrate now, copper is more active than silver, so it's going to bump silver out of the way. Silver is going to take on copper's electrons and come out as a metal. So silver will come out as metallic silver, and copper will turn into that pretty blue solution of copper 2 nitrate. So you will get an activity series on any quiz or exam. So copper is more active, it's stronger than silver, it bumps silver out of the way, silver will deposit as a pretty silver metal, the copper metal will be turned into copper 2 ion, and this will be a blue solution. Okay, my next question would be, is it balanced? No. Right now it says 1 mole of copper reacts with 1 mole of silver nitrate, produce 1 mole of silver and 1 mole of copper 2 nitrate. And that's impossible, because how can we just out of the blue gain a nitrate? We can't. So we're going to balance it so we can conserve mass and energy. I'm going to put a 2 there. That takes care of the nitrate. Now I have 2 nitrates, and I'm going to put a 2 there. So that tells me I have 2 silvers. So 1 copper, 2 silvers, 2 nitrates goes to 2 silvers, 1 copper, 2 nitrates. So we're balanced. Okay, I'm going to rewrite this equation and talk about the reduction and oxidation that went on. So I'm going to stop right there.